How do we obtain these Lissajous patterns?
हम हॉरिजॉन्टल एक्सिस पे खुद का सिग्नल भी लगा सकते हैं। इससे सुंदर सुंदर से डायग्राम बनते हैं, उनको हम लसाजस फिगर्स भी कहते हैं। ठीक है।
Namaskar, hello everyone and welcome to my YouTube channel. So in our previous video we had discussed that how a cathode ray oscilloscope can be used for the measurement of frequency. In today's video we'll be discussing another important, most reliable and quickest method for determining frequencies, and this is by the use of Lissajous patterns. So in order to know how these Lissajous patterns are formed, we need to start from the block diagram of the CRO, which is made over here, and we have already discussed about this in our previous videos. You can find the links of the complete CRO video series in the description box below. Here is a brief recap.
तो वो ब्लॉक डायग्राम दिख रहा है सबको इधर एक, है ना?
So we'll be focusing only on the major subsystems that are required. Vertical deflection system, the second one being the horizontal deflection system, third is your cathode ray tube, the fourth one being the high and low voltage power supply. The Y deflection plates, these are placed horizontally in a cathode ray tube, while the X deflection plates, they are placed vertically. So the frequency of the time-based generator, which controls the horizontal sweep speed, is primarily adjusted using this time per division control knob that you can find on the front panel of the CRO. So this time-based generator produces time-based voltage or sawtooth voltage, and it is this sawtooth voltage which provides the necessary horizontal sweep to whatever Y input signal that you are applying to the Y deflection plates. So if you watch this block diagram carefully, you will notice external X input.
अब एक और चीज़ कर सकते हैं हम, इंस्टेड ऑफ कि हम यहाँ टाइम बेस लगाएं, हम इधर एक और सर्किट लगा सकते हैं। CRO में बाय डिफ़ॉल्ट तो CRO में क्या है, टाइम बेस लगा हुआ है हॉरिजॉन्टल एक्सिस पे, बट हम हॉरिजॉन्टल एक्सिस पे खुद का सिग्नल भी लगा सकते हैं।
So in addition to the internal sawtooth voltage which is generated internally by this time-based generator, there is a provision for external X input as well. तो जब भी आप CRO को external मोड में यूज़ करेंगे, उस केस में अब जो horizontal sweep है वो अब sawtooth voltage नहीं देगी, वो वाली voltage देगी जो आपने externally दी है। तो जो हॉरिजॉन्टल स्वीप है अब कंट्रोल कौन करेगा, जो आपका एक्सटर्नल एक्स इनपुट होगा, सॉटूथ वोल्टेज नहीं, जो एक्सटर्नल एक्स इनपुट होगा, जो वो वेव फॉर्म होगी उसी के इन अकॉर्डेंस जो है आपका हॉरिजॉन्टल स्वीप आएगा इन दिस केस। और एक्सटर्नल मोड में ये जो एक्स डिफ्लेक्शन प्लेट्स हैं ये डिस्कनेक्ट हो जाएंगे इंटरनल सोर्स से, जो आपका सॉटूथ वोल्टेज थी उससे।
अब अगर मैं खुद का सिग्नल लगा दूं हॉरिजॉन्टल एक्सिस पे, फिर क्या होएगा, एक्स में भी मेरा एक सिग्नल है, वाई में भी मेरा एक सिग्नल है, उनकी सुपरपोजिशन हो जाएगी। अब अगर किसी को पता हो तो इससे लसाजस फिगर्स बनती हैं। लसाजस फिगर्स आर बेसिकली डायग्राम्स विच फॉर्म व्हेन वेव्स सुपर इम्पोज परपेंडिकुलरली। एक वेव ऐसे ऐसे आएगी, एक वेव ऐसे ऐसे आएगी, इससे सुंदर सुंदर से डायग्राम बनते हैं, उनको हम लसाजस फिगर्स भी कहते हैं। ठीक है। अब मेरे पास एक और मोड होता है जिसको मैं XY मोड कहता हूँ। इसमें क्या होगा, अभी ये चैनल 1 पे तो मेरे पास ये सिग्नल है, चैनल 2 पे मेरे पास ये सिग्नल है। ये बेसिकली क्या करेगा, एक्स एक्सिस पे एक सिग्नल लगाएगा, वाई एक्सिस पे दूसरा सिग्नल लगा देगा। तो अगर मैं इसको XY करूँ तो मेरे पास लसाजस फिगर आती है, विच इज़ बेसिकली द सुपर इम्पोजिशन ऑफ टू वेव्स परपेंडिकुलरली।
How do we obtain these Lissajous patterns? So these are obtained when two sine waves are simultaneously applied to both pairs of deflection plates. So you know that in a cathode ray tube you have this Y deflection plate and X deflection plates. So a sine wave should be applied as a Y input to this Y deflection plate, and another sine wave should be simultaneously applied as an X input to this X deflection plates. So you will be obtaining a Lissajous pattern in this way. Now the next question is that when do you obtain a stable pattern? A stable pattern like these. So the condition for that should be the vertical frequency and horizontal frequency. The ratio of these should be an integer or ratio of integers like this. So here vertical and horizontal frequencies refers to the frequencies of the Y input sine wave and X input sine wave respectively. So the ratio of these frequencies should either be integer as for this case or ratio of integers. Now another thing is type of pattern. You can see that here and these. These are different Lissajous patterns that can be obtained. So the question is, what decides that which type of pattern will be obtained? So one thing is the ratio of these frequencies, vertical and horizontal frequencies, as you can see from here. The other thing that decides that which type of Lissajous pattern will be obtained is the relative phase of these two waves. The relative phase of these two waves. Okay. So for example, for 45-degree phase difference and the 1:2 ratio for vertical and horizontal frequencies, you will be obtaining a pattern like this. So now with the help of an example, I will be showing you how these Lissajous patterns are obtained. So for this, you require a sine wave which will be acting as your Y input, and this Y input sine wave will be applied to the Y deflection plates. So in this case, my Y input is this sine wave. Clear? And another sine wave that will be simultaneously applied along with this Y input sine wave will be the X input sine wave. X input sine wave that will be applied to the horizontal deflection plates, and this X input sine wave in the present case is this. So we have two sine waves. This is my Y input and this is my X input. Now let us look at their frequencies. So you know that time period is the time that it requires to complete one full cycle of the wave, one complete cycle of the wave. That is the time period. So for the Y input sine wave, the time required to complete one full cycle is this, 12 units of time. So frequency is nothing but the inverse of time period. So if I say that nu1 is the frequency for this Y input sine wave, so nu1 will be 1/12. Similarly, in this case, the frequency for the X input sine wave will be 1/24. How? Because the time required in this case to complete one full cycle is 24 units of time. So frequency will be nu2, in this case nu2 will be 1/24. Hence the ratio of the frequency, the ratio of vertical and horizontal frequencies in this present example will be nu1 divided by nu2, which will be 2:1. So the ratio of this two frequencies, the vertical and horizontal frequencies, 2:1 in this present case. So hence you know that this condition of obtaining a stable pattern is satisfied because it should be an integer or ratio of integers. So you are getting 2:1, this thing is fine. So now for the sake of simplicity, let us assume that there is no phase difference between these two sine waves. You can see the starting points are same. So phase difference is 0. So the next question is that given that the ratio of frequencies of vertical and horizontal inputs is 2:1 and there is no phase difference between these two waves, which type of pattern will be obtained? So I say that this type of pattern will be obtained. But now let us discuss how this pattern is obtained. So Y input signal basically decides how to move vertically, like whether to move up or down at a given time instant, and this X input provides the necessary horizontal sweep to whatever Y input signal that you are applying to the Y deflection plates, and this horizontal sweep will be in accordance with the shape or pattern of this X input. So let us now observe how the horizontal sweep will be provided by this sine wave, this X input. Okay. So because this is acting as the X input, so I have rotated this sine wave like this 90 degrees because the horizontal sweep will be provided. This is not the vertical input, so I have made this sine wave like this. Okay, you can rotate it to 90 degrees clockwise. And now let us check the speeds at various points. You know that speed is determined by the position time graph, the slope of such a graph. This is nothing but the position time graph of the sine wave, and the slope of the graph at any time instant will determine the speed of the graph at that very instant. So as you can see that I have marked some points from 0 to 24 on this graph. So let us check the speeds at various time instants. So for calculating the speed, you need to know the slope at that very moment, at that very instant. So starting from this point 0, you see that this is the point of maximum slope. This is the steepest point, steepest slope. So the speed will be maximum at point 0. And as we move from point 0 to 6, from 0 to 6, the slope gradually decreases. the slope gradually decreases and finally becomes 0 at point 6. So speed will be maximum here and it gradually decreases and becomes 0 at point 6. Now from 6 to 12, what is happening? The slope is 0 here, speed is 0 here, and the slope gradually increases. Slope gradually increases and becomes maximum at point 12. So speed will again tend to increase gradually and it will become maximum at point 12. And the speed at point 12 will be equal to the speed at point 0 and both these points are of maximum speed. Okay? And from point 12 to 18 onwards, the slope again tends to gradually decrease and finally becomes 0 at point 18. So that means that at this point, at this very point, the speed will be maximum and it again tends to decrease and finally becomes 0 at point 18. And from 18 to 24, what's happening? The slope is 0 here and it again tends to slowly increase and finally it becomes maximum at point 24. So from 18 onwards, the speed tends to increase gradually and finally it becomes maximum at point 24. So if you want to imagine how this horizontal sweep looks like, let us look over here. So these points 0, 12 and 24, these will be the points of maximum speed. So 0, 12 and 24, I have marked these over here. So point 6 will be the point of 0 speed. The speed is 0 at point 6 and similarly at point 18 the speed is 0 because slope is 0 and slope is maximum at these points. Okay, horizontal sweep will be like this. So if we start from here, this will be the point. This will be the point of maximum speed. So when you pass these points 0, 12 or 24, you will be moving with the maximum speed. So from here to here, you will move with decreasing speed. The speed tends to decrease because the speed has to be 0 at point 6. So the speed is maximum here and 0 here, and in between it moves with decreasing speed. Maximum decreasing, finally 0. And now when we move from point 6 to 12 like this, the speed will tend to increase. The speed will tend to increase from 0 and gradually it will increase and become maximum at point 12. Now from 12 to 18, when we go like this, 12 to 18, the point will move with decreasing speed because the slope gradually decreases and the speed should be 0 at point 18 because it is the point of minimum slope. And from 18th to 0, if you move, you will be moving with increasing speed because the speed has to be maximum at point 24. So what will be the net motion? The net motion will look like this. Speed maximum here, slow 0, increasing maximum, slow 0, increasing maximum, like this. Okay. So now let us see how this Lissajous pattern is obtained. So we have discussed that this Y input will decide how to move vertically, like whether to move up or down. So you can see from 0 to 3 you are moving up vertically and from 3 to 6 you are moving down. So likewise I have divided these 24 points into some groups. In groups like this, 0 to 3, 3 to 6, 6 to 9. Okay, just to keep up with this vertical movement. So you can see from here 0 to 3 you need to go up, 3 to 6 down, 6 to 9 down, 9 to 12 up, and likewise. Okay, till point 24 I have marked these vertical inputs. Now let us check what will be the simultaneous horizontal input, the horizontal sweep that will be provided during these durations, during these time durations. So from 0 to 3, while moving up, you also need to move horizontally. Right, fast to slow. The speed will be fast, maximum here, and then you need to slow down. So likewise from 0 to 3, you need to move up. Fast here, but you need to eventually slow down as you reach this point 3. So you will be obtaining the pattern or shape like this. during 0 to 3. So from point 3 to 6 you need to move down vertically while simultaneously still keeping to the right, but you need to move very slow because the slope is gradually decreasing as we move from 3 to 6 and finally it becomes 0 at point 6. So from 3 to 6 you need to go down while still keeping towards the right, but you need to move very slowly. So gradually the shape comes like this. Okay. Now during 6 to 9 you still need to move down. You still need to move down, but how? You'll check from here. 6 to 9. 6 to 9, this was the case of 0 speed, and the slowly the speed is increasing. So slowly and slowly you are turning towards the left, but you are moving very slow. So you need to turn left from 6 point onwards and move very slow. So down, left and very slow. So this is the case where you see that the direction is gradually changing. You are turning towards the left but moving very slowly up to this point 9. From 9 to 12 you need to move up now. You need to move up. 9 to 12 up. The 9 to 12 you see that the slope is gradually increasing and becoming maximum at point 12. So 9 to 12 you need to stay left but slow to fast. You were slow here, but you need to gradually increase your speed because at point 12 this speed will be maximum and it will be equal to the speed at point 0. So 9 to 12 up but move with maximum speed towards the left. So the net motion will be like this. So you will observe a pattern like this. Similarly like this you can check for the other time intervals as well. Like from 12 to 15. 12 to 15 you need to move up. 12 to 15 up. But how? You need to stay to the left but fast to slow. The speed is fast and gradually it is decreasing. Fast to slow. So the shape is like this. 15 to 18. 15 to 18 down. Down. How? You need to stay left but move very slowly. You need to stay left but move very slowly. 18 to 21. Move down, still down. 18 to 21 down. 18 to 21. You need to start turning towards the right after this point, but you need to move very slowly. You need to move very slowly. So 18 to 21. You still going down but start turning towards the right hand side and moving very slowly. And from 21 to 24 you need to go up. 21 to 24 you need to stay right but slow to fast. Speed is slow here and gradually it will become maximum at point 24 and the speed will be equal to the speeds at point 12 and point 0. So you will be obtaining a pattern like this. So the Lissajous figure is this. So the final question that needs to be discussed over here is that how this Lissajous pattern can determine frequency. So as you already know that from this shape of this Lissajous figure, from this pattern, you can identify the ratio of the frequencies and the phase difference. For example, if I say that when will you obtain a circle, you will say that when the ratio of vertical and horizontal frequencies is 1:1 and the phase difference between the two such sine waves is 90 degrees, right? So you will be obtaining a circle in that case. So in order to determine the frequency of the sinusoidal wave, you need to apply a suitable sine wave whose frequency you need to determine as your y input. So that sine wave will be applied to the y deflection plates, right? To the other plate, to the x deflection plates, you will be applying frequency, another sinusoidal frequency, but you will be providing that with the help of a variable frequency oscillator. The frequency of such an oscillator can be varied. So you will be varying that frequency knob up to a point when you start receiving a stable pattern. When you start receiving a stable pattern, and once you receive such a pattern, you will notice the frequency corresponding to your x input sine wave. You will notice that frequency.
जितनी ज़्यादा दोनों सिग्नल्स की फ्रीक्वेंसी मैच्ड होती है उतनी अच्छी लसाजस फिगर बनती है, उतनी कम नोड्स होती हैं.
So once you get a stable pattern, you will be noticing the corresponding frequency, and that frequency will be the frequency of the x input sine wave. For example, you get a stable pattern like this and you will be noticing from the readout the frequency, जो variable frequency oscillator है, that will tell you the frequency corresponding to this x input, and that will be nu 2, and you have the value for that frequency over there. So next thing is you identify which type of pattern you are getting. For example, you are getting this. Now your problem is solved because you know this ratio, you know the ratio of vertical and horizontal frequency. You will check from here. So this is 1:2. This means that nu1 over nu2 is 1:2 if you are obtaining this pattern. So nu2 is already known, nu1 can be found. So hence you can find out the frequency of the Y input sine wave.